An Alpine-based container image can fit into less than 10 megabytes, but doesn't make it faster, safer, and automatically better than Debian, Ubuntu, or any other base Linux for that matter. Let's find out! Alpine Linux is an open-source, community-led Linux distribution. It can be used on servers, VMs, embedded systems, bare metal, but it became particularly popular as the base container image for containerized workloads due to its small size. This is because it was designed to be as minimalistic as possible and at the same time preserving all core Linux capabilities. So binaries are thinned out, but there are a lot of packages in the repository. So developers can add only packages they require, leaving the unnecessary dependencies out. But there is actually more to Alpine than just cleaning out the clutter. There are 3 features that contribute to its small size: musl libc, BusyBox, and APK Package Manager. Let's start with musl. Most mainstream Linux distributions use glibc C standard library. glibc has 35 years of history and a reputation for being bloated. On the contrary, Alpine uses musl. Musl is a smaller C standard library designed around simplicity and efficient static linking. Compared to glibc, musl has less legacy functionality and fewer platform-specific optimizations. Therefore, it has smaller static and dynamic overhead. So, musl requires less space, and actually it can be considered more secure because of a smaller attack surface. The performance depends on the workload. In some cases, musl is more performant, in some less. Most applications are compatible with musl, but some of them require portability fixes and patch sets. BusyBox is a set of command-line Unix utilities. It was originally created for embedded operating systems. It comes as a single executable file and contains smaller, simplified versions of 400 common Unix utilities. The size of BusyBox is around 1 megabyte. As such, it provides a compact environment for system maintenance. And it is also customizable. Commands and features can be added or removed. Alpine also uses Alpine Package Keeper, or APK, as a package manager. The APK tools package is smaller than YAM or other package managers, and so it also adds to Alpine's size optimization. Plus, Alpine packages are intentionally thinned out and split into sub-packages. So, teams have more control over what they install, and the distro stays as small as possible. So why should you consider using Alpine Linux or any other minimalistic Linux for that matter? Well, first, you get smaller deployment artifacts. And the smaller your images are, the more you can save on cloud deployments, because you need less registry storage and can achieve better density. Then there's package granularity. Teams can construct images for their workloads instead of starting with a bigger general-purpose environment. Another Alpine advantage is the pull speed. Rapid pull times can save on traffic and can help increase team performance due to reduced waiting time. Security is also a benefit, but with a small asterisk. On the one hand, a smaller package set reduces the attack surface and the number of components requiring patches. Plus, the Alpine team releases security fixes regularly. But security does not end with small size. You still need regular rebuilds, vulnerability scanners, CVE management, provenance data, and proper runtime controls. If Alpine Linux is so great, why don't we all just migrate our workloads to it and live happily ever after? Well, it's never that simple. Alpine is small, clean, and fast, yes, but some of its benefits may turn into drawbacks for some teams. Take musl libc, for example. In many cases, its performance is equal to that of glibc, but there are benchmarks that demonstrate inferior musl performance in some multi-threaded environments. Plus, musl may be less performant for certain Java workloads. Setting performance aside, there's also a question of compatibility. Precompiled native binaries often target glibc. Sometimes they may require recompilation, compatibility packages, or other workarounds to be able to work with musl. Also, Alpine is community maintained, which is also great on the one hand. You get the spirit and the freedom of open source, you use cutting-edge technologies, and the Alpine team actively maintains and develops the project. But on the other hand, some organizations may require contractual support, strict SLAs, or longer controlled maintenance windows. In this case, they may require another option. But are there any other options? Well, luckily, Alpine is not the only minimalistic Linux distro for containers. Some good alternatives include Alpaquita Linux, Chiseled Ubuntu, RHEL UBI Micro, and Wolfi. Alpaquita Linux has two flavors, with glibc and optimized musl, whose performance is equal to or superior to glibc. It is developed and supported by Bellsoft, open source but with optional commercial support, and is a base Linux for Bellsoft hardened images. Chiseled Ubuntu is part of the canonical ecosystem. It is a minimized version of Ubuntu that you can cut out yourself for your specific workload using the tool called Chisel. RHEL UBI Micro is glibc-based and, of course, seamlessly compatible with Red Hat's infrastructure. Wolfi is also glibc-based, but uses APK. It is maintained by ChainGuard and is the base Linux for ChainGuard containers. I have already compared all these 5 Linuxes in my previous video, so you can watch it for more detail. To sum up, Alpine is small because it strips down non-essential packages and substitutes some Linux components with their minimal alternatives that can produce excellent container images, especially when network transfer, storage, and attack surface matter. But Alpine is not automatically faster, compatible, or safer. Choose it only when its trade-offs match your workloads, and consider Alpine-compatible alternatives when they do not. If this video was useful to you, don't forget to like it, subscribe to our channel, and until next time!